Hello guys, welcome. This is Deepika from MyTutorialRack.com, and in this tutorial we are going to see how it's all done, what is the trick behind this whole magic of AI, right? Doesn't AI feels like magic? Because what AI can do is kind of blows my mind, right? You can use tools like Midjourney to create images. You can use a car in a driverless mode where it can take you from one destination to other. It will change the lanes. It will do everything for you, right? You can use ChatGPT. You can ask ChatGPT to write an email to send it to your students and wishing them a happy new year or happy Thanksgiving, right? So all these things, it looks so magical. So what is the trick behind this magic? How is this magic done, right? So if I have to explain to you in a very layman's term, it is nothing but the kind of data we have fed over a period of time, and based on this data, now it's able to predict a lot of things because it has that kind of information, right? So now what AI can do may seem like magic, and like magic, it is natural that we want to see what's going behind this magic, right? And what you will find is that the computer scientists and researchers are using lots of data. They are doing some kind of math on it, and then the processing power. This is all it is to get you this magic, okay? So they are not using mirrors or misdirections like the magicians use. What they use is they're using lots of data. They're doing some kind of math on it, and you are doing a processing power. All these things makes AI magical. A lot of programmers for decades, what we have done, right? Programmers have written code that takes an input, processes it, and using a set of rules and returns an output, correct? Now, this is how the programmers have worked, right? Programmers, what they have done is they write this instructions, they give it to the computer, and then we feed an input to this instructions and it generates an output. For example, if I have to calculate an average of given numbers, what do I need to do is I need to first add those numbers and then divide it by the total numbers that they are there. If there are 4 numbers, I'll divide by 4. If there are 3 numbers, I'll divide it by 3, right? So those instructions, that's how to calculate an average of a given number, those instructions you have written in a particular language, and then you feed an input, and then the input acts on that instructions and generates you an output, right? Now those instructions are also called as algorithms, correct? What is an algorithm? Algorithm is nothing but the simple set of rules for turning an input into an output is an example of algorithm. Let's say I have to calculate the average. What do I need to do? I need to add the numbers first, and then I need to divide by the total number of the numbers are there, right? So that's what I have to do. Now, algorithms have been written to perform some pretty sophisticated tasks, but let's say if there are a lot of rules and a lot of exceptions, you cannot write an algorithm to get you those answers because there is so many different use cases or different scenarios in order to get you an output, right? For example, if you have to estimate how much time it takes me to go from point A to point B, how many factors it plays, right? The rain play an important factor. The traffic conditions play an important factor. The road conditions play an important factor. Is there an accident on the road plays an important factor. What time of the day it is. Is it a school zone? Is it during the school zone timing? Or is it raining outside? Is there an accident on the road? Lot of things play an important factor. So you cannot create a algorithm to give you those kind of answers, right? But some tasks have so many rules and exceptions that it's impossible to capture them all in a handcrafted algorithm. So, and some things are learned by experience, and that's where the AI works. It is based on the experience. Now, for example, let me give you an example here. For example, let's say you have to grab a milk from Walmart. Okay, so this is your home, and let's say you're doing for groceries. Simple, you're going to the Walmart and want to grab milk, right? And let's say you want to capture how much time is the total time taken from point A to point B and then back to point A. right? Now let's say this is what you have to calculate, and it depends on several factors. It depends on, is this a weekend, okay, and what time of the day it is it raining or not, what is the total distance to the store, and total minutes for the trip. This is what we want to calculate, right? This is the task that we have to calculate. Now let's say you started with an Excel sheet, okay, you created an Excel sheet, and in that Excel sheet what you did was you decided what day it is, okay, it's a Monday, Tuesday, Wednesday, Thursday, or what's a weekend, then what time of the day it is, okay, is it raining or not, and then based on these factors you are calculating the total time. Okay, this is what you are doing. Every day what you do is, on a given day, if it's a Monday, you went at 9 o'clock, okay, now you know that weekdays is not where people actually go for grocery. People prefer going on groceries, majority of the people go on groceries on weekends, right? And it was not raining that day, and it took you about 30 minutes in and out, coming back to the house, about 30 minutes to grab a milk, okay? Now similarly, let's say you went on Monday again at the same time, let's say 9 o'clock, but at that time there was rain, and if the roads were kind of messy, there was accident on the roads, and this time it took you about 45 minutes, and based on that you started preparing this Excel sheet, right? Now the same Excel sheet, if we feed, and there are a lot of scenarios, okay, and sometimes rain will play a major role, sometimes the weekend will play in a major role. So let's say on a weekend, okay, it was a Saturday, you went early in the morning, okay, time also plays a very important role. Early in the morning people usually don't go for grocery, people go around between the timings of 1 and 5, people like to do their groceries, right? So let's say it was a Saturday, you went at 9 o'clock, it was not raining, let's say, and this time it took you about only 30 minutes, right? This took you about 30 minutes to grab your milk and come back. Weekend, because it was early in the morning, it took you less time. Now the same time you went again, it was raining, but it was a Saturday, again it was not many people were there, and it took you about 35 minutes, right? So there are so many different scenarios. You kept feeding it, and based on that you provided a weightage, right? Each input has a certain weight. The weekend is more powerful than if it's raining or not raining, right? Weekend is generally going to be more busier, people usually go. Now at the same, on a weekend you went around 2 o'clock, it's going to take you about 60 minutes to do. So the weekend plays a much bigger role. So you started giving weightage to that input, and that, okay, this input affects more than this input. After several trips, you start getting a feel for how conditions affect how long it will take. Like rain makes the drive longer, but it also means fewer people are shopping. Your brain connections between these, and then you come to a conclusion, and that's what it tells you, that this is the estimate, right? So how this same thing we are doing with the AI also. What we are doing is we are feeding this information, and we are weighting. We have provided a weightage for every input, and we first start with the same weightage for all the inputs. For example, weekend, what time of the day, how much rain it is, all of these are given equal weightage in the beginning, and this is how we are calculating the total time. Now let's say we realized that based on this, if we gave an equal weightage, our estimated time was not up to the mark. It was too off from the real time. So then we decided that, okay, weight plays the weekend plays a very important role. So let's give the weight a higher number, and then rain also plays another factor. So it also going to get some more weightage, and the time is also plays an important, but not that effective. Okay, so now here the weekend plays a very big role, so you give a different weightage. And now let's say this kind of gave you closer to the estimated time. That means you're in the right direction now, but it's again little far from the total time. Then you said, okay, does rain plays a similar role? Then you increase this one also. Okay, time doesn't play that much role, so you leave it. Now your estimation is much closer to the actual time. So that's how you plan. You keep changing it, the weightage, and you keep coming with the solution. And if you see the solution is actually matches to your estimate, that's how you will learn, and you'll provide these weightage. So there can be n number of scenarios, or we can call it as n number of nodes. Okay, so how AI works. So the first step is, just like we were trying to calculate how much time it's going to take us to go from our house to the Walmart and bring a bring a gallon of milk. Okay, so assign all your inputs a weight. I've already explained to you, but let's cover the theory. Assign all your inputs a weight. This is a number that represents how strongly an input should affect your output. It's okay to start with the same weight, because in the beginning we started with the same weight, but then we realized that giving same weight to everything is not giving you the correct estimate. Number two is, now use the weights with your existing data and to estimate the minutes to milk run. If we can compare the estimate to the historic data, it will be way off, but that's okay. Now let the computer guess a new weight. Okay, for each input, making some a little more adjustments, right? You say some inputs play a much bigger role, so you increase the weight of some others inputs, you decrease the weight of some inputs, and you see how much time it is giving you now. And if it matches, we are good. Otherwise, you redo this calculation until you reaches a particular output which matches your exact output. Okay, so what it is, these are nothing but we increase the weightage now, rerun the calculation to check if the new weights result in a better estimate, and if so, it means the weights are a better fit and changing in the right direction. Now you keep repeating this 3 and 4 steps and letting the computer tweaks the weights until the estimates aren't getting any better, and you keep doing it. At this point, computer has settled on the weights for each input. It knows what matters the most. If you think of a weight as how strongly an input is connected to the output, you can make a diagram that uses this line thickness. We have decided that. Okay, so going from point A to grab a milk is just one scenario, but there are so many factors involved. There are so many exceptions. So you can see here, for example, the weekend afternoon, and it's a shiny day, there's no rain, will take much longer. So let's give it an adjustment of +5. When we do the maths to calculate an estimate, it results in a larger number. Now we know that while we're at it, let's give the weekday morning rain scenario an adjustment of -4, since we know milk runs are the shortest at that time. So based on that, you are calculating, you're feeding, you're seeing, okay, is this correct? No, it's not. Okay, rerun those calculations with different weights, and you come up with these different scenarios, and you do some math around it, and that's when you get your outputs. Now, what we are calling as, this is called as the neural networks that we are forming. Okay, we can train an AI model by letting it guess and check the importance of weight of each input. Okay, so what is the weight of each input? Is this input is for +5, -4, how much weight that input takes? So that is what we have formed. Okay, so now here the next thing is the web of connections guided by the weight and biases in example of a neural network. So we are forming these different nodes, right? Nodes are nothing but scenarios, right? The web of these connections guided by weights and biases is example of neural network. Each of the scenario that we discussed is called a node. What is a node? The scenarios that we discussed. What day of the week it is? Is it raining? Is it a weekend? Is it how much time it's going to take? If it's a weekend, what's the time you're going for the milk run, right? If it is raining at that time, how's the traffic condition? Is there an accident? So these are different scenarios. To summarize, neural networks are a mix of nodes, layers, weights, and biases. Weights is nothing but kind of like biases and a bunch of math. Okay, that forms your neural network. Neural network is a mix of your nodes, the layers, the connection between those nodes, the weights, biases, and bunch of math. Together, they mimic our own organic neural network. Each neural network is carefully tuned for a specific task. Okay, so each neural network that we have, it can only do a specific task. Okay, like say, for example, if you want to predict the weather, then that is a neural network you'll form for weather. If you want to drive in the driverless car, you have to form a different neural network, and that is a different task that it has to do. Maybe it's great at predicting rain, maybe it categorizes the plants very well, or maybe it keeps your car centered in the lane on the highway. So depending upon what task, it is going to have its own neural network, and based on what neural network it has, that is what it is going to predict better. Whatever the task, neural networks are a big part of what makes AI seem magical. Okay, so that is what we have, is the neural network. In this video, I gave you an explanation of the magic behind the AI, okay? And the magic lies in the data, in the math, and also the computational power. I hope this tutorial was crystal clear. I'm going to see you in the next video. and stay tuned. Thank you very much and have a wonderful rest of the day.